Hey all, here we're going to talk about some more logic, and in this lesson we'll talk about two laws, the law of detachment and the law of syllogism. You need to know those words and you need to know these laws. The first one we'll talk about is detachment. In the law of detachment, we're going to have one conditional statement right here, if P then Q. So if we have a conditional statement, if P then Q, and then if we also have an example of the hypothesis or an example of P, the thing at the beginning in between if and then we're able to make a conclusion in context about that conditional statement, and then based off of the example of P. And the conclusion we can draw is about Q in the conditional statement. So we're given a conditional, we're given an example of the hypothesis of the conditional, and then we can make a conclusion or draw a conclusion about Q, which is also called the conclusion of the conditional statement. That's a little abstract, so let's do an example. So we're going to draw conclusions here. That doesn't mean we're going to make pictures. It means we're going to come we're going to come to some sort of conclusion at the end of this information. Sometimes we cannot draw a conclusion, and that's if we don't have an example of P. So let's read this. If a student gets an A on a final exam, then the student will pass the course. So I like to identify which is P and which is Q. So P is a student gets an A on a final exam. Q is the student will pass the course. So we have a if P then Q. And then down here we have Felicia got an A on her history final exam. Getting an A on a final exam, that's an example of P. So we have, like the law says, if P then Q, and then an example of P. So the conclusion that we can draw is that Felicia will pass the course. So we're using our original if P then Q, and we're using the example of P to draw a conclusion about Q. So Felicia will pass the course. Bye, Felicia. I want to do another example. We can call this a non-example. We're going to try and draw a conclusion. In my conditional, my P is two angles are adjacent. My Q is they share a common vertex. So I have an if P then Q. Down here I have angle 1 and angle 2 share a common vertex. That's actually an example of Q. That doesn't fit the law of detachment. So we cannot draw a conclusion. So we're going to say no conclusion possible. We have the if P then Q, but the law of detachment says that we need an example of P. But we have an example of Q. It doesn't work that way, so we'll just say that we can't draw a conclusion. Go ahead and please pause, and if you can, draw a conclusion about this scenario. So again, I'm going to identify my P, and I'm going to identify Q, and then let's see if this is an example of either of them. P was there as lightning, Q is it is not safe to be out in the open. Marla sees lightning from the soccer field. That's an example of there being lightning, an example of P. So we do have the law of detachment. So we can conclude it is not safe to be out in the open. Or you could say it is not safe for Marla to be out in the open. something like that. The next law is the law of syllogism, and in this case we have two conditional statements: if P then Q, and if Q then R. Notice that the conclusion of the first conditional statement then becomes the hypothesis of the second conditional statement. If we have a situation like this, we can conclude a third conditional is true: if P, then R. So again, if in our first conditional the conclusion is Q, and in our second conditional the hypothesis is Q, so the same idea, the same thing, then we can kind of eliminate Q and just put if P, then R. Let's do an example. I have two conditional statements here. If a figure is a square, then the figure is a rectangle. So I'm going to start labeling P, Q. Then we have if a figure is a rectangle, then the figure has four sides. So in the first conditional, the figure is a rectangle was Q, so I'll label that Q here. And then the figure has four sides is a new piece, so we'll call it R. So we do have if P then Q, if Q then R, so we can conclude if P then R, which is if a figure is a square, then the figure has four sides. So we sort of cut out the middleman, and we have another conditional statement. I have another example. This is one to show you what it looks like when we cannot draw a conclusion. I have if you do gymnastics, that's my P. You are flexible is Q. In my second conditional, you do ballet is the hypothesis. That's a new idea. We'll call that R. You are flexible is Q. This doesn't fit the law of syllogism. It says if P then Q, if R then Q. That's not how the law goes. So here we could say no conclusion possible. So pause here, please, and if you can, draw a conclusion about these two statements. So again, I'm going to show P and Q. A whole number ends in 0 is P. It is divisible by 10 is Q. Here it says a whole number is divisible by 10. That's the same idea. It's worded just slightly different than Q from the first, but we can call it Q. It is divisible by 5. That's new. We'll call that R. So we have if P then Q, if Q then R. That's the law of syllogism. So we can conclude if P then R, which is if a whole number ends in 0, then it is divisible by 5. Again, if a whole number ends in 0, then it is divisible by 5. I got 3 you-do problems, so please do them. In the first one, actually, all I want you to do is draw in conclusion, sorry. So there's 3 examples. You'll have to determine whether or not it's detachment or syllogism, or if it's neither, which means you can't draw a conclusion. So give those 3 a shot. Use the previous examples to help you, and I'll answer questions in class.